Hi, I'm Stefan. Welcome to the TwoStack Developer channel. Today I would like to introduce you to something new that I created. That's called Bitcoin in a box, or Node in a box, if you will. If you remember that the last few episodes, I've basically been looking at first how to set up a Bitcoin node in regression test mode, but then also how to go through the process of programming your first transaction. Now, I've basically created something which will make this whole process just a little bit easier for you to participate in. And that is a Docker containerized instance of the Bitcoin node, which is pre-configured to already run in regression test mode. And that's what I'm going to be showing you today. So let's get started. Okay, so right now I'm actually looking at my Docker file. The Docker file is extremely simple. And I'll just quickly run through here. There's not a lot to go through. It derives from the Ubuntu distribution. I set up some prerequisites. I download version 1.08 of the BitcoinSV Node software from bitcoinsv.io. I create some soft links in the right places. And then I just basically set up folders and directories. I create a cron job, which I'll talk about in a second. And then I launch I run this launch script, which is essentially the one that will start up the Bitcoin daemon. Now, the only interesting thing really to talk about here about this cron tab or this cron job that I created is that it will run the automatic block generator every 10 minutes, or rather it will automatically run the Bitcoin CLI command generate one block every 10 minutes. Now, this is so that it's more for the sake of convenience, right? That basically means that every 10 minutes, you will get a new block. It will hopefully alleviate some of the tedium of having to come back and forth and generate blocks as you're trying to put your app together. This way you can focus on building your app and sort of have the assurance in the back of your mind that, okay, the blocks are going to get generated automatically. I can just keep poking at the node as and when I need to. You will still need to generate the first 100 blocks if you want to actually use or get usable testnet coins out of the node. Let's take a quick look at how the Docker container actually is put together. Okay, so I'm going to open my terminal. I'm in the repository, or rather in the main folder for the software now, and I will just basically do a build, right? Docker build the Docker file here with the tag, and I'm going to call it TwoStack Node. It's going to go away and build. Now, I've already built this once, so it'll go quite quickly now because it doesn't have to fetch all of the images from upstream. Okay, so Docker image ls. Let's look for TwoStack. There we go. We've got TwoStack Node. It's 280 megabytes big. Let me quickly run this. Docker run. Let me make sure I don't have anything running in the background now. No. So Docker run TwoStack Node in the background. Okay, it's running. There we go. Quizzical bows. Now I'm going to attach. I'm basically going to jump into the node and basically look at basically get an interactive shell directly inside the Docker container. So I will get an interactive shell for, what is this, 80FAD, and I will use a bash terminal. Okay, so now I'm in. And let's take a quick look around. Let's see what's running. Not a lot running. I've got the cron job running. And if you look at a list of the cron tab entries, you basically have this one entry which will generate output, and it will write whatever it generates to the Coinbase log. I just noticed I need to update this. this is going to run every 1 minute right now. I need to modify that. Okay, I'll update that and modify it for every 10 minutes. Right now it's running every minute. So by the time that you watch the video, the source code on GitHub will be updated. So when you pull this, you will be able to just go ahead and it'll be fixed. All right. What did I just do? Okay, I'm poking around. Yeah. So I've got the cron tab. Now, if you recall before, I needed to basically punch in a long command like bitcoin-cli, specify the data dir, blah, 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 blah. We won't have to do any of that now. Right now, I can just go bitcoin-cli get block count. Boom. There we go. I've got 2 blocks mined already because it's mining blocks every minute right now. What is this, Litecoin? No, we're on BitcoinSV. Sorry, that was unwarranted. You should not be taking stabs at other guys or other blockchains. Let's now take a look at a couple of commands that we can run that can form sort of a general base for working with. And I'm going to list all of the commands that I think are generally useful to know when doing application development. You will at some point need at least these few commands in order to be able to usefully interact with your node in development mode. I will now switch over and I will open up the application that we built as part of the building a transaction project, because we will use that. We won't be doing any coding. We'll just use the output from that application to basically create a transaction that we can submit and do some of the other things that we need to do. Yeah. Okay. To the code. All right. So this project should look familiar to you. Let me maybe make it a little bit smaller so that it looks. Yeah, you can see that this is pretty much what we did yesterday. I can take this just the way it is and I can run it and I should get a transaction out, right? Right, there I get a raw transaction out. Now the first thing I'm going to do is I'm just going to take this raw transaction. I'm going to go over to my node in a box. Okay, clear that. Go over to my node in a box. Where did I put this? Oh, it should be running in Docker. Right, so I can just go docker exec -it 80fa bin bash to get an interactive shell again. And basically what I want to do is the output that I just got from this run, which is this here, I'm basically going to try and transmit this, right? I'm going to say, okay, bitcoin-cli send raw transaction, this, my raw transaction. I'm going to hit enter. It's going to say, no, you can't send that. You have missing inputs. And what this error means is that the inputs in my current transaction that I have from the example that we did references outputs that don't exist inside this container. So there is no UTXO for us to spend from, right? So this is sort of a nonsensical transaction because it's attempting to spend from a non-existent UTXO. So we'll get this kind of error. To fix this, we will have to do what we did before, which is take one of these addresses, which is Alice's address, right? So we go to Alice's address and we fund Alice's address with some of the coins that we can get from our node. And for that, we will use two commands which are useful again. The first one is to check the balance, and that is get balance. And this gives us the balance of the wallet inside the node. and I can now generate 101 coins just to make sure that I can get some coins put into, whoa, look at that. I have 400 bitcoins in the wallet now. All right, and then I'll do what I did before, which is to send bitcoins to Alice's address. I'll say bitcoin-cli send to address, and I'll send 10 bitcoins, the same as what I did before. Then I'll grab the transaction ID. I'll come over to the application, and I will paste this new transaction ID in here. Let me make that a little bit larger, okay, so that it's a little bit more obvious, and I'll make this window a bit smaller. Now, the Alice's raw funding transaction, which is the one that we just, to which this transaction ID refers, we need to get that raw transaction in order to be able to properly compose the inputs that reference the outputs, the UTXOs. So the UTXOs we want to refer to are in this funding transaction. So let me do that now. And that is bitcoin-cli get raw transaction with this transaction ID, which is the same one as what we were just given on the command line here when we sent from our Bitcoin wallet to Alice's address. Right? And then we get this raw transaction, and it's this raw transaction which I will now take over to the application, which is Alice's funding transaction, and I will paste it in there. Right? And now we should be able to run the application again. And when we run the application, the output, the raw transaction output, or the serialized transaction that we end up getting from it, that should be a transaction that we can broadcast locally. Okay, so let's do that. Run the application. Okay, now this transaction should be one that we can transmit. Let me clear this console again. This transaction should be one now that we can transmit. So I will say again, bitcoin-cli send raw transaction. This one should be accepted. Mandatory script verify flag failed. I have no idea what that is about. Okay, so just now we tried to broadcast the transaction that we got from the application, right? So we grabbed the transaction that we got here. We went to the terminal. We did a bitcoin-cli get raw transaction, or rather send raw transaction, and then it blew up. It said, nope, you don't. Op equal verify operation failed. And this is a good opportunity for us to actually use the tools to try and debug and try and figure out the sort of thing, what actually went wrong here. Now, I went and did a bit of poking, but I'm going to bring you along for the poking that I did. The first thing that I did was I wanted to confirm all the parameters that I'm actually passing in to the transaction builder, as well as to the transaction signer. And what I discovered, and maybe you can see this, maybe you'll see this as well, and I'll introduce the next useful command, which is to decode the raw transaction. But the raw transaction I would like to decode, and you might get a hint from that, is Alice's funding transaction. Let me decode that. I'm going to say bitcoin-cli decode raw transaction. I need to get the raw transaction from that transaction ID, and then I can decode the transaction that I just got. And when I decode it, and I want to go and look and see, let's look at the outputs in this transaction. So here are the inputs. Here are the outputs. One output spends 40 bitcoins back to the sending address, the sending wallet, which is the Bitcoin wallet, and the 10 coins which we want is in output number 1. These are the ones that are coming to Alice. And if we look in our application, what would we see but the fact that we're actually referencing output index 0, right? So we need to reference output index 1 from Alice's funding transaction, both for where we say we're spending from Alice's transaction, right? We need to reference the transaction and the index of the output that we're spending from, and then when we perform the signing, we provide the UTXO that we are signing over from the funding transaction, and we reference that by its index, which is 1 as well. So if I run this now, because those are the only two places where we actually reference the index of the UTXO. If I now generate this and I go and try and spend it, and you're coming along with me again now, because obviously I can't double spend it, I haven't retransmitted it. Fingers crossed that it actually goes through this time. So Bitcoin CLI send raw transaction, and now I'll try to send it again. And there we go, we have it. Yeah, so we've got a transaction ID, no errors. So I can now just go Bitcoin CLI get raw transaction. I can ask for the transaction from them. I already have the raw transaction, but just for the sake of, then I can say Bitcoin CLI decode raw transaction, so that it can basically take it apart for me and then provide me with some values. And here we see us sending the 10,000 Satoshis to what we have before as Bob's receiving address, right? And that does it for that part. The CLI commands that I've basically just covered in this are basically ones which refer to the local wallet on the Bitcoin node. The two ones there which are of primary use is get balance and send to address. The commands we use for generating blocks, which is Bitcoin CLI generate, that is particularly useful as well. And then of course, when it comes to trying to debug and try to figure out what went wrong, decode raw transaction, that is particularly useful as well. And then for broadcasting the raw transaction that we've actually composed, we can do a send raw transaction. I hope you enjoyed this episode. Yeah, and I will see you around next time.